Hi, everyone. So great to have you all here for the first in this series for our Stata with Dr. Chuck Huber. And I just want to introduce myself and just give a little bit of background, and then we'll get rolling here. I'm Dr. Marissa Erickson. I'm a principal statistician with Bird through ICTS, and we have quite a few of our staff here as well. So I'm representing one of the two units on campus that offers statistical consulting services. So the first is Bird through ICTS, and the other is the CSC Consulting. So we offer this sort of workshop as a part of our mission. And so we have a really great lineup of workshops through, and this Stata series is one of many. And we also have some SPSS workshops if anyone is interested in those, and I will be leading those coming up. So we can also follow up with more information through, if you're interested, please chat. That kind of leads me to the next thing. So we will be monitoring the chat. But also, if you have a question, like we'll be monitoring, but if you have a question, please feel free to just jump in and come off mute if you have something. And then also, just as a reminder, so Margaret, who's also here, is our business manager, and she will be posting an evaluation survey link in the chat. We would really appreciate taking a little bit of time, 3 minutes or so to fill it out. It helps us offer more free courses as well. Okay, and then I'm going to turn it over to Chuck. I'm first going to just read a quick bio for Chuck. So Chuck Huber is Director of Statistical Outreach at StataCorp and an adjunct associate professor of biostatistics at the Texas A&M School of Public Health and at the New York University School of Global Public Health. In addition to working with Stata's team of software developers, he produces instructional videos for the Stata YouTube channel, writes blog entries, develops online net courses, and gives talks about Stata at conferences and universities. Most of his current work is focused on statistical methods used by behavioral and health scientists. He has published in the areas of neurology, human and animal genetics, alcohol and drug abuse prevention, nutrition, and birth defects. Dr. Huber currently teaches survey sampling at NYU and introductory biostats at Texas A&M, where he previously taught categorical data analysis, survey data analysis, and statistical genetics. Everyone, please welcome Dr. Huber.
Thank you. I really need to shorten that. That's too long. So
Oh, it's great.
anyway, okay. Thank you very much. So let's go ahead and get started. Let's find the share button here. Whoops. Sharing is not turned on. Send request. Is Margaret still here? Oh yeah, there she is. Okay, yeah. Okay. We'll be ready
Okay,
in
Chuck, you
just a
should be all
second.
set. Sorry about that.
Okay, no problem. Let's see here. Table share. Okay, can you see the slides now? Okay, cool. All right, so today we're going to be talking about customizable tables with Stata, and I'm trying to squeeze as much as I possibly can in because there's a ton of stuff you can do with this, and we're barely going to scratch the surface. You can download all the slides, the do files, and the data sets at this tiny URL. So if you just go to tinyurl.com/stata tables, I pasted this link into the comments window a little while ago, and so you may be able to just click that link in the comments window. And I'll put this up again, again at the end. I also just realized I updated these slides this morning and I haven't put the slides in the folder yet. So you might want to check back tomorrow because if you download it right now, you're going to have the old version of the slides. And I've added some cool stuff to it today. So check back later this afternoon or tomorrow and I'll get the slides I'm using now in there. Okay. So here are some examples of tables you might want to create. So this is kind of a classic table one that just shows descriptive statistics, often by some exposure variable or treatment variable or something. So in this example, I have things like age and sex and race and health status by hypertension status, yes or no, and then I have a totals column here. So you might want to create a classic table one, something like this. Often we also might want a table of tests. So in this case, I have a bunch of lab tests, things like serum albumin and things like that, also by hypertension status. But I've included a statistical test to see if they're equivalent across the two hypertension categories. Um, People often use this to compare their groups in the beginning, just to make sure they're somewhat equivalent, or not equivalent, or whatever they want to do with them. But anyway, I call it a table two. This one I've called table four. There is a table three I'll show you in a little while, but this is a table of a collection of statistical models that I've fit that I might want to compare different models. So, for example, I have the covariates age, diabetes status, and health status. This is all for a logistic regression model for hypertension, risk factors for hypertension. And so what I've done is I've fit a model that only includes age, a model that only includes diabetes, a model that only includes health status, and then a full model here on the far right that includes all of the covariates. And so I have their odds ratios and confidence intervals in here, and I have the number of observations and the pseudo R squared and the AIC and BIC for each. So this is another table that you might use for comparing models. So I'm going to show you how to create these. So I'm going to back all the way up though and talk about the basics of creating any kind of tables, and then we're going to work our way up to that big table at the end. It sounds like someone has their microphone maybe on. If everyone could just make sure that your microphones are off, it's creating some background noise. But if you have questions, please feel free to unmute and just jump in and ask your questions along the way because I can't see the comments window. So, okay, well, we're going to start with basic tables and collect, which is a companion command that we're going to be using sometimes. And then I'll show you how to create these. The data set that we're going to be using is available online. It's called NHANES 2L. I know it looks like NHANES 21, but it's actually 2L. I don't know what the L is for. And it's available over the internet. You can just type WebUse and Stata and then NHANES 2L. And it has it's based on the NHANES data, National Health and Nutrition Examination Survey data. We're going to ignore the survey weights. You don't have to, but I'm going to just to make it a little simpler and easier to read. But we're going to be using variables like age, sex, race, height, weight, BMI, cholesterol, things like that, blood pressure. So those are some of the variables that are included in this data set. So let's start with the table command. I guess I should back up and say there are three main commands, or four really: table, collect, dtable, and then etable. So those are the four commands. Table is the most basic, and it's kind of flexible for just creating any kind of table that you like. So this is the table dialog box for the table command, and it has a lot of tabs in here, and it's a very sophisticated dialog box. It has lots of tabs, lots of options and things in here. And I'm gonna jump out for just a second and see if I can figure out whose mic's unmuted because I'm
Also,
getting a
Chuck, can you
lot.
can you repeat the four types of table commands, please, when you get back to it?
Absolutely. I'm just trying to
Thank
figure
you.
out whose microphone is on because I'm just getting so much ambient noise. It's kind of distracting. Um, Here, I think I found it. Whoops. Okay, well, it seems to have stopped. All right, I'll go back to sharing. Sorry about that. Yeah, so there are basically four commands that you can use. The most basic is the table command, and it's used for making any kind of table. And then you can use a command called collect. There's a companion command, and I'm going to show you both of these. But table and collect are sort of the background of all of this. And then there are two additional commands: dtable, as in descriptives table, and etable, as in estimation tables. Those are convenience commands that are running table and collect underneath. And they make it a little quicker and easier to create tables of descriptive statistics and estimation results. But the workhorse here is table and collect. So that's what we're going to be looking at. So anyway, table has this very sophisticated dialog box. You can specify the row variables, column variables, table variables, and put in margins, customize the margins, and everything about what's in them. We're not really going to use the dialog box here today. I'm going to focus on the syntax. But just be aware there is a dialog box, and you can do pretty much everything I'm going to show you with the dialog box. So at its most basic, the table command is followed by two sets of parentheses. A set of parentheses for row variables, and that's variables plural. So you can have more than one row variable, and column variables in the second set. And that's also plural. So you can have more than one column variable. So I'm not sure why it's not fast forwarding. There we go. So as a quick example, I could type table high BP. High BP here is just high blood pressure. And if I put high BP in the first set of parentheses, that makes it the row variable. And then I have an empty set of parentheses after, which is the column variables. And I don't have any column variables in this case. Now, I could leave out the second set of parentheses and Stata wouldn't complain because it would know then that high BP is the row variable and it would just assume there are no column variables. So that would be how I would create a quick table of just rows of hypertension categories. Now, if I wanted to put hypertension, high BP as a column variable, I do have to include the first set of parentheses and leave them empty, and that's how Stata knows that high BP is a column variable. Okay, so row variable, you don't need the second set. Column variable, you do need the first set of parentheses. Okay. Now, if I include a variable in both, in this case, sex would be the row variable and high BP would be the column variable. So now I'm doing a cross tabulation. Notice that a couple of things. By default, what table is going to populate the table with is the counts, the number of observations in each of those cells. It's also going to show you by default the totals for each of the rows and columns. So for instance, for sex, male, I have 2,611 males in the 0 hypertension status category. And then I have a row total. I have a row total for female, and then I have a total for sex by hypertension status. It's automatically going to put the comma in the thousands places. If we had bigger numbers, it would put the commas on all of them by default. So it's really handy for just creating really quick tables of cross tabulations. If you want to get rid of the totals, you can use the no totals option. Now, this is really cool. If you've ever used the old table command in Stata, you're going to like this, or at least I do. What I'm going to do is type no totals, and that gets rid of all the totals, row, column, everything is gone. And then what I can do is I can customize which totals I want to put in by variable, not by rows and columns. The old command used rows or columns. Now, because you can have multiple row and column variables, you can specify precisely which variables you want to see totals for. So in the top table here, I've included totals for high blood pressure. In the bottom table, I've included totals for sex. If I could put them in for both, or I could just omit that and have it put all the totals in. But what that's going to do is just specify the totals then for either the rows or the columns that you specify. Okay. Now, I can also include, as I mentioned, multiple row and column variables. So in the top table here, I've typed table and then put sex and high BP both in the first set of parentheses and nothing in the second set of parentheses. And I've used no totals here just to make the table smaller so I can fit two on a slide. But notice in the top table, I have sex and high BP. Sex is before high BP in order. In the bottom table, it's the same idea, but I've reversed the order of the variables high BP and sex. And when you change the order, it changes the nesting structure of the table. So in the top table, I've specified sex first and high BP second. So that means categories of high BP, high blood pressure, will be nested within categories of sex. But in the bottom table, I've reversed that. High BP is first, followed by sex. So now categories of sex will be nested within categories of high BP. So the variable order in the parentheses has meaning. It is important. And that's another way, a thing you can use to customize the look and feel of your tables. Okay. I could do the same thing with columns. So I've just done the exact same thing, only put them in columns. And again, on the top table, categories of high BP are nested within sex. In the bottom table, categories of sex are nested within high BP. Same idea, though, it's just columns. I don't know if there's a limit. There must be, but I haven't found it, and I don't know what it is. And you're limited more by page space than the software. But you can include three or more variables in a set of parentheses. So here I've nested diabetes categories within sex, which are nested within high BP. So you can have three or four variables of nesting in here if you want. again, you're probably limited more by table space, page space than you are by the software. Now, what I could do here is at the bottom, I'm going to specify totals only for high BP. Notice I have both sex and high blood pressure as row variables, but I'm only specifying the totals for high BP. So that's what I mentioned earlier is that you can, rather than just specifying row totals for all of them, you can customize it for specific variables, even when you have multiple variables in for rows and columns. So that's the very basics of just doing cross tabulations for frequencies. But of course, at some point, you're probably going to want to put some sort of statistics in those cells. So we can do that with the statistics option. So there are lots and lots of stats. The frequency statistics are either the basic frequencies or the sum of the weights. So if you have weighted data, such as survey weighted data, you can have it give you the sum of the weights rather than the counts because they'll be different. So you can specify either one or even both if you wanted to. You can also specify the proportion, the percentage, the raw proportion, or the raw percent. Again, either ignoring or including the weights. So this has been set up so that you can use this with survey weighted data, and that's why we keep specifying with or without weights. And then I don't know if you can even read this because there's so many, but there's just this blizzard of different statistics that you could specify. Means, standard error of the mean, standard error of the mean using the binomial distribution, standard errors using Poisson, variance, standard deviation, skewness, kurtosis, and so on and so forth. Any percentile you want. So P number means if you, for whatever reason, wanted the 37th percentile, you could get that. Or just do Q1, Q2, Q3 for the quartiles, things like that. So lots and lots of options for placing statistics in your table. You place them in there using the statistics option. So for instance, I might want a table using high BP as the column variables, and then I could have the frequency as one statistic and the percent as another statistic. By the way, I guess I should mention this because not everyone's aware of this. When you're typing in a batch file, these triple slashes at the end of a row, at the end of a line, means that the command continues on the next line. So this is all one, it's 3 lines, but it's all one big table command. And I use those a lot to make it a little easier to read the table commands because they can become fairly large. So again, those triple slashes mean the command continues on the next line. So this would be both rows. I'd have a row variable sex, column variable high BP, and I'm also including the frequencies and the percents and the cells. Okay, so I can get both of those in here. Now I'm going to get rid of the totals. I'm going to use that no totals option again to give myself some space here. And then I'm going to add some more statistics. So within each cell, I might want to add something like the mean of another variable like age, or the standard deviation of another variable like age. So each cell can contain lots of information if you want to. And I don't know that there's a limit to this either. I think you could specify probably 10 or 15 of these. I've not bumped into the limit on those either. Okay. Now, at some point, you're probably going to want to format the numbers. So for instance, here we have, for instance, the standard deviation is displayed with 4 decimal places of accuracy. We probably don't want to see that. So we can specify the display format using 2 different format options. One is called N format. N format formats the look of the number itself, how many decimal places, things like that. And then S format formats the string around it. So if you want to add any strings to it, like a $sign or a percent sign or things like that, or put parentheses or square brackets around things, you would use S format to do that. So let's look at this first. Inside this red box here, I have N format %9.0 FC frequency. What that tells Stata is that I want to format the frequency. Frequency is the variable or the thing, the statistic that I want to format. And I want to format it with 0 decimal place, 0 digits to the right of the decimal place. The 9 tells it I want to give it 9 digits of space in the cell. And the FC means fixed. Fixed means store it, display it this way no matter what. And then the C is for comma. That adds the C in the comma place. That looks like the default. In fact, that is the default, but I've just specified it explicitly here so you can see it. The second row in the red box there says S format, and this looks really strange. It says Inside double quotes, it says percent S, percent, and then another double quote for percent. So I should have maybe chosen a different example because it would be less weird. But the percents, you need to put those on either side of the string that you want to do. So S is the string, that's or the number, that's the thing you want to put the string around. And then I want the percent to follow the percent, the actual number that's being displayed. But I do need the percents on either side of that. And so that's why you have the double percent, the S percent followed by another percent. You just need those percents on either side. So that's how I added the percent next to percent. And then in format, I want to also format the mean and the standard deviation. So I'm going to include those with two digits to the right of the decimal place. And then for the string on that, I want to put parentheses around the standard deviation. And so that's what that bottom S format in the red box does. Okay. Note that for in format, I can use the specify a numerical format for multiple statistics all at once. I've done that for both the mean and the standard deviation in one in format option. Okay. And so that's that way you can customize the statistics that are in the table itself. Okay, so that's the very basics of table. We've not even begun to scratch the surface of everything you can do with it. So I do want you to be aware of that. I'm just showing you the very most basic things you can do. There's lots more you can do with it. But that's kind of the basics. And one of the things you can do once you've created a table is use the collect command to further customize it. Now, there is a tables builder, so you can go over to this builder and use this to customize things. And as you can see down this left column, there are a bazillion things you can customize to do with your tables. The fonts, the font sizes, whether it's bold, the color of the fonts, the color of the numbers and the thing. It's entirely customizable. We're not going to use the tables builder here either, just like we're not going to use the dialog. I'm going to focus on using the syntax because that's the kind of thing you can put in a do file and run it over and over again. But anyway, so let's start with the table command that we just ran. So let's say we run that table command. It creates our table. When you run a table command, it automatically creates something called a collection. So what is a collection? A collection, in this case, is going to be called table. A collection, you can imagine, is almost like an imaginary data set that's floating in Stata's memory. It's not a data set. You can't see it. If you click on the data editor, you can't see it. It's sort of a construct that's floating in Stata's memory. But the table is kind of like an imaginary data set. And inside this collection, you have dimensions. And so a dimension is kind of like a variable in a collection. Okay. So I have dimensions in my table, and here I've typed collect dims so I can see the dimensions that are in the table. Again, this collection is automatically created when I run the table command. So if I type collect dims, I see the collection is table by default, and I see all these dimensions, things like layout, style, header, label, and I have weird words like across, CMD, set call name. And some of these look like the variable names I used, high BP, sex. Those are variable names that I put into the command, the table command. But other things like stat CMD and var, and then style only. These are also dimensions, style dimensions. So a collection like table contains all these dimensions, and we can customize these dimensions. Notice that these dimensions have different levels. The levels are kind of like the categories of a variable. So I used to have a slide. I took it out because I just have too many slides in here. But a collection is analogous to a data set. A dimension is analogous to a variable in a data set. And the levels in a dimension are analogous to categories of a categorical variable. So why do we have this? What it allows you to do is customize your tables without messing with your data. So for instance, high BP, and I did this on purpose, high BP is not labeled in the data set. So I can type collect levels of high BP and it will show me this is the collection table, the dimension high BP, and the levels are 0 and 1. Again, this looks a lot like we're talking about a data set with the variable high BP and the category 0 and 1. Same idea, but I can modify these without modifying the data set. This is just an imaginary thing floating in Stata's memory while I'm working on this table. So I can type collect levels of and see the levels of high BP of that dimension. And then I can also list All of them. Look, collect label list, list all the different levels of it. Now, notice there's a .m here. .m refers to the total. That's always there because that's what would be placed in the table as the total. So that's always going to be there and it's already labeled. What I might like to do is label the levels of high BP. Now, this command, if you ignore the part that says collect label, blah, 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 this looks a lot like we're labeling the categories of a variable, and it's the same concept. So if you've ever typed label levels, what is it? Label level. Anyway, we're going to
Values.
label what? I'm sorry? Values.
Values, I
Label.
think.
Yes, thank you. Label values. That's what I was trying to get at. So label values in a variable name. I'm going to type collect label levels and label the levels of the dimension high BP. So then I'm going to type 0 and put no in double quotes and then 1 followed by yes in double quotes. So that's going to add those labels to the dimension high BP. So now when I create my table, oh, I can also change the label for the dimension as well. So this is like typing label var and then changing the label of a variable. So collect label dimension high BP hypertension. It already had a label, so I'm going to have to put comma modify to modify it. And now that's going to change the label from high blood pressure to hypertension. It's just a little shorter and easier to place in the table. So now when I type collect preview, this allows me to preview what the changes that I've made. The table now shows hypertension as the dimension name and yes and no as the level labels. Okay, now why would I want to do that? Well, sometimes you do different styles of table for different things. You may have different reports for different organizations or different reporting agencies. You may do different table styles for different journals. If you're submitting papers to different journals, they may have different rules and things. And so you would like to be able to customize all your labels without messing with your data set. You don't want to have to go through and change the labels of your values and variables and all that for your data set. This allows you to customize the tables without messing with your data set. Now, you don't have to do this. If you wanted to, you could just make sure you label all your variables and the values of them how you want, and then these will all automatically look the way you want. Table does pull the variable names and the value labels from the data set. But if you wanted to change them without changing your data, this is how you would go about doing that. Okay. And again, that's the rationale, is that way you can customize your tables without messing with your raw data. Okay. I can also look at things like collect levels of results, so I can see what these various results are. That's another dimension in the collection. Results. So I see these things in here like frequency, and frequency is labeled frequency with a capital F. SD is maybe a good example. The level, the dimension SD is labeled standard deviation. Okay. So I could go in and change those if I want to. I could type collect label levels, result is the dimension, frequency is one of the levels, and so I can change that name to FREQ dot if I wanted. Mean, I could specify mean and put age in parentheses to label it clearly, and so forth. So again, this allows me to go through and customize any of the labels for my table without messing with the raw data. Now, some people, and this is weird, there are two kinds of people in the world, people who like that vertical line and people who don't. And strangely, inside of Stata Corp, people really don't like that vertical line. I was surprised how much uh, passion there was about this line. So if you want to remove that line, it's in there by default. If you want to remove that line, you can type collect style cell border block and then customize the border. Now, if you're looking at that command and thinking, wow, that's a really crazy command just to do that one thing. Yes, it is. And part of the reason is that you can, when I say you can customize anything, you literally can customize anything. So you could go through and on that border, on the right border, change the pattern to nil. You could change the pattern to double or dash or dotted or whatever. So you can go in and change those lines to anything, including nothing. Nil just means don't draw it. Okay. But you could also change the color of it, whether it's dashed or dotted or whatever. So when I say you can change and customize anything with collect, you pretty much can. It's in there somewhere. And that's why these commands tend to look a little bit intimidating at first because it's so customizable. Okay. Once you're done creating your table and you're happy with it, you can type collect style put docx, and this is just to put it into a Word document, and you can put it into PDFs or HTML or LaTeX or whatever you want. But I'm going to put this into a Word document, so I'm going to type collect style put docx, and then specify layout auto fit contents. Now, why am I doing that? If you don't run that line, what it's going to do is stretch, and this isn't a Stata thing, it's a Windows, I mean, it's a Word thing. Word will automatically stretch that table across the entire width of the document. And it looks really strange. And so I always run this collect style put docx layout auto fit contents. And what that will do is make the table look nicer once it exports. It keeps Word from stretching it across the entire document. Then you can type collect export and tell it the name of the document you want to export it to. I called it my table docx, and then that's implied once you put docx. Stata knows it's going to Word, but you can put in as docx, and then I've created it many times, so I put replace in here so it will overwrite the old one. You could append. So if you want to do append this to an existing document, you would just put append in here. Anyway, and so then it will export it to Word, and this is what your table would look like in Microsoft Word. There's a little screenshot at the bottom. Okay. So I've shown you how to do this in Word, but again, you could export it to HTML, PDF, Excel, either the new version or the old version of Excel, LaTeX, Stata's markup language, SMICL, plain text, or even Markdown. So those of you who like using Markdown, either as dot Markdown or dot MD. Now, because each of these document types have their own options, you do have to specify those when you export. So if you type collect export as PDF, that's a different set of options. And so you need to go through and read what options are available for which document types. So a lot of these things are limited by the document type. So for example, PDF, you really can't customize PDFs as much when you create it, at least as far as I can tell. If you really want to customize it, I would suggest creating the document as a Word document, and then we have a command in here that will convert it from a Word document to a PDF document. There is a static command that will do that for you. Because the Word documents it's much easier and you have more control over how you format the Word document. And then as the last step, just convert it to a PDF. Or if it's just quick and dirty, you can go straight to PDF if you want. Okay. So I've collected all of those commands on one slide just so you can see how to do that. If you wanted to create this Word document right here, this is the syntax that you would use to do that. Now, at this point, you may be looking at that page of syntax and going, oh, geez, that's an awful lot of work to create one table. And that may be true, but I would make a couple of points. One, once you get used to this, it's really easy to do. You can copy and paste this over. These formats and things like this, you can just copy and paste, change the row and column variables, and away you go, because chances are you're going to use similar formatting for table after table. Two, I would point out that with collect, if you label your variables and levels and things like that in your data set the way you want them from the beginning, there really isn't a need to go through and use collect label levels and collect label dim and all that. I'm just showing you how to do that so that you know that. So that really isn't necessary. It's just a customizing feature. So that's not really necessary if you label your variables and their values clearly to begin with. The other thing is, and I'm not going to show you this here, but there is a way to store styles, what are called styles. So if you have a style for a particular journal, you need the fonts to be a certain font. You need a certain number of decimal places for the mean and things like that. You can actually, and I took it out. I used to have a lot more stuff in here and I had to remove it because it just got too long. It is possible to save a style. And then you can just call that style anytime you want. So then what you do is you just run your table, your raw table, and apply that style to it with all the collect stuff, all of the frequencies, how you put the number of decimals and percent signs, all that can be stored, saved, and applied to other tables later. So if you're going to be using this a lot, I would suggest learning how to do that, because then what can happen is, let's say you submit a table to one journal, your paper is rejected. You go to submit it to another journal. Well, gosh, they have different table standards, so you've got to change it. If you if you submit papers to the same 4 or 5 journals over and over, I would suggest creating a style for each of those, and then it makes it really easy to just rerun your tables for your manuscript, and you just change the style to the other journal format. So it takes a little bit of work in advance to do that, but once you've done it, it saves you a ton of time in the future. And then the other thing is if you're going to do reports, regular reporting, weekly, monthly, annual, quarterly reporting, it's definitely worth the time to set this up and customize your tables exactly how you want, because then you don't have to do it. You can just run them over and over again. Okay. So don't let the syntax intimidate you. I've kind of shown you an extreme here of customization, but it doesn't always have to be that elaborate. So any questions up to here? That's just the basics of how to create a table. So far, so good.
Chuck, I had a quick question. You were saying that the main difference between and if you could go back to the syntax real quick.
Certainly. Yeah, let me scroll up here. Okay.
Yeah, the in format and the S format. I noticed for all the S format commands, you actually have parentheses around the command, versus in the in format, you don't have parentheses. Can you just again explain the differences between those two?
Um, are you talking about this S format that says S percent S in here?
Yeah, and I noticed that you have, I said parentheses. I'm sorry, I meant quotes. Um,
Oh,
and you
oh,
don't have quotes in the syntax above in the in format.
right. I believe that I don't know this. I'm kind of speculating, but because it's dealing with strings, what's going to happen is probably underneath the hood, underneath in Stata, what it's doing is temporarily converting that to a string so it can add other characters to it. Because when you're formatting the numbers, you need to treat the thing in the table as a number. So you can specify the numeric format, how many decimals and all that. I'm going to guess that when Jeff is the guy that wrote this, when he's applying those characters, those then get converted to strings. And because they're converted to strings, that's why the double quotes have to go around them. Because now you're adding non-numeric characters, things like parentheses or percent signs or dollar signs and things like that. And so at that point, it's no longer a number, it's actually a string. So I think that's why. I'm kind of speculating. Um,
That's super helpful. Thank you.
Yeah, it's hard to get inside the head of Jeff because Jeff is a certifiable genius. But I'm kind of thinking through the logic here that the numbers have to be treated as numbers to format them as numbers, and then the strings would have to be once you've done applied the numeric formatting, then you convert them to strings, and once it's a string, you have to have the double quotes. That's my guess. I don't really know. Okay. Any other questions? That's an interesting question. I hadn't thought of that. Any other questions before we move on? You're probably looking at the clock now going, oh, there's no way he's going to finish. But once you get that part, the rest of this is pretty straightforward. Okay, so let's look at how to create a table of descriptives, what I often call the classic table one. So this is a different command we're going to use called dtable. Dtable is what's called a wrapper command for table. So dtable is running table and collect underneath. So everything could be done with table and collect. In fact, it is being done with table and collect underneath. Dtable just makes it a little bit easier. Okay. And so we're going to switch commands and use dtable, and it has its own dialog box called dtable. So at its most basic, if I just type dtable, it's going to show me the number of observations in the data set. So type dtable, you get the n, how many observations. Then I could type dtable followed by a continuous variable like age, and by default, what it's going to show me is the number of observations. That's always going to be there by default. And then it's going to show me age followed by the average or the mean age, and it's going to put the standard deviation in parentheses next to age. So that's the default behavior. So dtable, put in a continuous variable, you get a mean and a standard deviation. Okay. Now, I could do this by a categorical variable. So if I were to type dtable age, comma, by high BP, what that's going to do then is it's going to show the descriptives for age by categories of high BP. So now I have no hypertension, yes hypertension, and then the total column. Total is included by default, just like it is with table. So you're going to get The count and the frequency or the percent here for no, yes, and total. Same thing for age. You'll get the mean and standard deviation for the no category of hypertension, yes, as well as the total. So that's the default. Below that, I went ahead and added in the continuous option just to show you how to specify that. Now, this is still the default, but what I can do is then change that and customize it however I want. So if I type D-table age by high BP, next to that as an option, I can type continuous and then put the variable age in first and then comma statistics mean SD. So that's how I would specify what statistics do I want to see for the continuous variable age. Okay. Now I'm going to start stacking these because it becomes too hard to read sideways. So now I'm going to start customizing this more. I'm going to type dtable age. So age is that continuous variable by high BP. I'm going to leave in that continuous age statistics mean SD. And then I'm going to specify N format and S format, just like I did with table. Okay. So I'm going to specify the numeric format for mean and SD for age is going to be 1 digit to the right of the decimal place. And then I'm going to add that percent next to the standard, excuse me, not the percent, the parentheses around SD. Now, you're probably asking the question, the same one you just had, why are there no double quotes around that string? And I don't know. I'd never really noticed that before until you asked the question. And now it's like a big bright light glaring at me. Why are there no double quotes there? I don't know. He probably just made it easier with dtable so you don't have to specify that. But anyway, so just like with table, you can customize the numeric formatting and the string formatting of its display in the cells. Okay. So that's for a continuous variable. If I want to add a continuous variable into my table, I can customize the statistics, the numeric formatting, and the string formatting in the table. Now, what if I have a categorical variable like sex? Well, dtable uses Stata's factor variable notation. So in order to tell dtable that a variable is categorical, you just put an I dot in front of it, just like in a regression model. If you wanted to tell regress that sex is categorical, you put an I dot in front of it, and it creates indicator variables for you. Dtable uses the same kind of factor variable syntax. Just put I dot sex, it knows it's categorical. And now what it's going to do is show you the variable name first, sex, followed by the categories and their value labels, male and female. And then it's going to show you the frequency as well as the percent. Okay, so that's the default behavior for a categorical variable. Now, just like with the continuous variable, I can use, instead of the continuous option, I'm going to use the factor option. So that's the factor variable or categorical option. I want to do this for all categorical variables. If I don't specify a variable name, I could have typed sex here before the comma. But if I want to apply this statistics to all categorical variables, I just leave the variable names out and then put statistics, FV frequency, and FV percent, which stands for factor variable frequency and factor variable percent. And then again, like with the continuous variable, I can specify the numeric format. So here I'm just going to customize for the numeric format for the frequency. I want no digits to the right of the decimal place, and I want commas in the thousands place. That's what the 0FC is for. And then the second in format option specifies 1 digit to the right of the decimal place for FV percent. Now, because it's FV percent, Stata automatically puts that percent sign in there for you. So there's no need to add that manually. It just does that for that particular statistic. Okay. So I can combine these. So what if I type dtable, age as a continuous variable, sex as a categorical variable by a high BP. Now I have these 3 options for the continuous variables, continuous, N format, and S format. So that's the same thing I had before. And then the bottom 3 options, factor, N format, and N format, that formats the factor variables, the categorical variables. So I can combine those with continuous and categorical variables. Now all I have to do, once I've gotten it the look and feel how I want for the continuous and categorical variables, all I have to do is go in and add more categorical and continuous variables. So here I've age and sex were in here before, and then I've added I.race, I.healthstat, I.diabetes in the first row. The second row, I've added the variables weight, continuous variables weight, height, BMI, BP systolic, BP diastolic. The rest of this, the next 5 or 6 rows, are the exact same options I had in there before. Notice for the continuous option, I did remove age from that option before the comma. So it applies the statistics mean and standard deviation to any and all continuous variables. I've also at the bottom added a title. I've used the title option to add a title to my table. I've used the note option to add a note at the bottom. And then the very last line actually exports this to a Word document. So all that one dtable command will create this table. And then at the very bottom, it says collection table exported to table1.docx. So this is what it would look like in Stata. And then I can export it. And this is what it would look like in Microsoft Word. Okay. So that's how easy it is to use dtable to create a table like this really quickly. You could, again, it's being done in the background using table, but dtable just makes it easier. You don't have to specify all the formatting and things like that. So that's it. That's how quick and easy it is to create a classic table one. Okay, any questions about that? Okay. So it's a short walk to do a table of statistical results. We're going to do the same thing we did before. We're going to take our same dtable command and we're going to modify it slightly. So for a continuous variable like vitamin C, inside that by option where it says by H high BP, I'm going to put in these options. First is no totals and then tests. I don't have to have no totals in there. I could leave it, and so then I could have both the totals column as well as the test column. Problem is, I run out of room on the slide and it makes it hard to read. So that's why I've specified both no totals as well as tests. Tests is going to add a statistical test down the right-hand side to test whether or not the means are equivalent across the groups. Now, it depends on, in Stata Smart in the background, it's going to run whatever the appropriate statistic is for comparing either 2 groups or 3 groups or whatever. And so in this case, it's using the regression style test to test whether or not the means are equal across the groups of the mean of serum vitamin C is equal across the groups of high blood pressure. So that's where that p-value comes from. I can do the same thing for categorical variables. So say I had heart attack and high BP, which is essentially a cross tabulation. What it's going to do in the background is run a Pearson style chi-square to test for association between heart attack and high blood pressure. And then it'll simply put the p-value there in the right-hand column. So that's how you would do that for a continuous variable or a categorical variable. All you have to do this for lots of variables is, again, you just put in all of your variables at the top, and then in your option by, just put in no totals and tests. The rest of this is exactly like it was before. All of these options, the S formatting, the N formatting, the title, the notes, the exporting, all of that stays exactly the same. And so what that does then is creates this table where I'm testing the equivalence for both the categorical variables. Again, it's like a cross test of association for heart attacks and high blood pressure, as well as testing that the mean serum albumin is equal for the categories of hypertension. And again, it's choosing the test statistic for you in the background based on the number of categories and whether it's categorical or continuous. I believe, if I remember correctly, there is an option for doing some non-parametric type tests and other things in here as well. I could be wrong because Jeff is just constantly adding things to this. And with Stata Now, I don't know if you're familiar with Stata Now, but we don't hold things until the next release. We just sort of release things as we go now. So it's kind of hard to keep up sometimes. Anyway, and so this exports to table 2. And so this is what that table would look like in a Word document. Okay, so any questions about that? Okay. So next up, let's look at the E-table command. So what if I have regression results and I want to present those in a table? So the rest of these are going to be focused on estimation results. So I'm going to be using the E-table command. So there is a dialog box for E-table. And again, this is a wrapper command for table and collect. It's actually running table and collect in the background. So we're again not going to focus on the dialog box. We're going to focus on the syntax, so it's reproducible. But you could do all of this, everything I'm going to show you with the dialog box. So let's say that I run a logistic regression model for high BP. So high BP is my binary dependent variable, and I include the variables continuous predictor age and the categorical predictors diabetes and health stat. That's why I have the I dot in front of those. So I get my output here. I see the odds ratios, the standard errors, the z-statistics, p-values, and confidence intervals. So let's say that I'd like to report this in some sort of a table that's going to go in a manuscript, or maybe I just want to see it in a report for model building purposes. After I run that command, I can just type etable. And if I type etable, this is what I get. So I'm going to get the odds ratio. So whatever is reported in the output, in this case, it's the odds ratio. So by default, it's going to show you the odds ratio. If it was a regression coefficient, it would show you the regression coefficient. If I typed logit instead of logistic, it would show the coefficient. But I used logistic, so it's showing me the odds ratio and then the standard error of the odds ratio underneath the odds ratio. Okay. So I see that for each category of diabetes and health status. I have the intercept in here as well as the number of observations. So that's the default behavior of etable. Now, this is a really cool feature of etable. I can type comma replay, and it will replay whatever the last version of etable I ran was. Well, right now, that's not very interesting because all I did before was type etable. But what it allows me to do is add new options and not have to type them all at once. So, for example, I could type etable, comma, replay, and then I'm going to add the option keep age, diabetes, and health stat. So what that does is keeps those variables, and the net effect is it just removes. There's no way you can remove the intercept. What you have to do is keep the variables that you want. So I'm going to keep age, diabetes, and health stat, and that removes the intercept from here at the bottom because we don't usually display the intercept for logistic regression models. Okay. So the next command, I'm going to type etable replay, and it's still the keep option is still used because of replay. Whatever the last version of etable I ran was, that's what's going to run again, and it's going to apply the new options that I'm including. Okay, so I have another option here called cstat. Cstat is for column statistics. That's for whatever I want to put in this column here. So one of those options, and I'll show you a list of them shortly, but one of them is _R_B. That is the coefficient or odds ratio or whatever the thing in the left-hand column of the regression output is. In this case, _R_B is our odds ratio. And inside that cstat option, I can apply a numeric format. So here I'm using in format inside that cstat option. So I want to display the odds ratio with 2 digits to the right of the decimal place. And then I'm going to add a second cstat option to display the _R_CI, which is the confidence interval. So in this case, I'm going to specify CI delimiter comma. So I want to put the comma in there. And then the in format formats the number, the display of the upper and lower bound of the confidence interval. So again, I'm going to display that with 2 digits to the right of the decimal place. Okay. So that's what the cstat options do. And you can put lots of things in that cstat option. R_B is the coefficients or odds ratios or whatever, hazard ratios, the standard errors, the test statistic, whether it's a Z or a T. Even if it says Z here, if T is reported in the output, it will report the T rather than Z. It depends on the command. And then I can have the p-value in here, or just the lower bound, or just the upper bound of the confidence interval, or the entire confidence interval. If you're using Bayesian methods, you can report the credible intervals, the upper or lower bound, or the whole credible interval for Bayesian estimates. Or if you want to hide things, just put _hide and it will hide them. So these are options for the cstat option. Okay. Now I can replay that, and I might want to add stars. This is something that's often done in tables and manuscripts, academic manuscripts, is to put stars. Rather than reporting the exact p-value, you just report whether the p-value is less than 0.05 or 0.01 or 0.001. So what I can do here is type show stars will show the stars automatically. So if I put show stars, the default is 0.05 and 0.01. So if there's one star next to a coefficient or an odds ratio, one star indicates less than 0.05, two stars indicates less than 0.01. Those are the defaults. What I can do with the stars option is I can specify my own whatever I want. So I could type in 0.05 and 0.01 to keep the defaults and add a 0.001 and make that 3 stars. So I would have to do that manually, but it allows you the flexibility to use whatever cutoffs you want and display them here. And then I want to attach those stars to _R_B. So that's what that stars option. Now I can also use the option show star note. And what that will do is add a note at the bottom of the table to indicate what the stars represent. So that way people, if they see 3 stars, will go, I don't know what that means. 3 stars represents P less than 0.001. So it's just a way to customize the display of stars and add notes to the table. Okay. Now, what if I want to add model level statistics? So I could, and again, replay is keeping everything I've done before, all the previous options, and now I'm going to add some MStat options. So MStat allows me to add these model level statistics. So N is already in the table, number of observations, but I might want to customize it. So I'm going to use MStat N, that's the sample size for the model. And then I want to customize it so I have no digits to the right of the decimal place, and the C puts the commas in the thousands places when it's displayed. And I also want to change the label to observations, so I can change it from number of observations here in that table to just observations. It makes it a little shorter, takes up less space. Or I could change it to N if I want, but you can change the label to whatever you want. And then I have 2 more MStat options. One is AIC for Akaiki's information criteria, the AIC, and I'm formatting that as well with no digits to the right of the decimal place and adding the comma, and same thing with BIC. Okay, so those are model statistics that are added to the bottom of the table. There are lots of these that can be added, so you can have the number of observations, the F statistic, the chi-squared, the log likelihood, the R-squared, adjusted R-squared, things like that. I believe this is dependent on the model that you just ran. So, for instance, there may be some other things that are unique to a particular model that you've run that will be populated. So you may need to check that to be specific. I don't show it in the slides because I just don't have time, but it is possible to run estat commands. So, for instance, estat, oh gosh, what is it? Estat. Oh, I'll think of it in a moment. But if you wanted to see, for instance, the sensitivity and the specificity and things like that, you can get those from eStat and place those in your tables as well. That's up on the website. And I would just refer you to the manual to see how to do that. It's a bit more sophisticated, and I just don't have enough time and slide space in here to put it. But it is possible to add other numbers using MStat. I can also add a title for my table using the title option. So I've called this Table 3 Logistic Regression. And then I've also added a note here that specifies the data source for my table. If I want, I can change the column label. Notice the column label by default is high BP, the variable name. But I might want to label that with something a little nicer like the DV label, the dependent variable label. So I've changed that to high blood pressure. So whatever the dependent variable label is, that will be placed as the column label. Okay. And the options then would be the dependent variable name, DV label is the label. You could label it with the command if you wanted. You can show the command title, the estimates, index. There are lots of options. I'll show you one more using estimates here in a moment. Okay. So finally, I could then export this using the export option. So I'm going to export this to table3.docx, and that then sends it to a Word document. Okay. Now, I think in the interest of time, I'm going to go, because it's really quick to go from here to multiple models, I'm just going to run through that, and then I'll just take generic questions. So if I wanted to, this is the entire etable command that would recreate that estimates table that I just showed you for one model. Okay. So first I have to run the logistic regression model, and then I run the etable command, and it will create that table. Okay, now let me show you one quick trick. One of the things that I prefer, and I'm told this is a difference between economists and other statisticians, economists in their journals like to put the estimate on top and a confidence interval or a standard error below that. Let me scroll up. It may be easier to see here. So here we have the odds ratio followed by the confidence interval underneath the odds ratio. And I'm told that in econometrics and economics journals, that's how it's done. And that's the default behavior in Stata. If you wanted to put the confidence interval next to the odds ratio, let me show you a little trick for how to do that. We're going to dive into collect. So I'm going to type collect composite define. What that allows me to do is define a composite statistic. I can take several, one, two, three statistics, combine them into a single thing. So I'm going to create a new statistic called ORCI for odds ratio confidence interval. And what that's going to do is combine the odds ratio and the confidence interval into one statistic, again called ORCI, and trim will remove any spaces that are unnecessary in there. Then what I can do is type collect layout, and collect layout will then show me the layout of the row, the layout of the layout of the columns. Now, why do I need that? Because this is how the table command is being defined underneath. And I would never think of how to put that together all by myself. That is the row. Like if you went into the table command and typed table, that's what goes in the row parentheses where it says rows. And then the thing that says etable underscore dv labeled stars, all that, that's what goes in the column parentheses. So that's pretty sophisticated. And that's why etable makes it so much easier to do these things. So what I need to do is see that. I need to find out what the row and how the row and how the columns are defined. Then what I'm going to do is substitute in that row definition where it says underscore R underscore B space underscore R underscore CI, the thing underlined with the red line. I'm going to substitute ORCI for that. So the stuff with the red line, I want to substitute the stuff with the green line. And I'm going to do that by typing collect layout, and in the first set of parentheses, put that row definition. Second set of parentheses, that's the column, put the column definition in there. And now I have my odds ratios with the confidence intervals to the right of them, next to them. Okay. So if you prefer to see your odds ratios and confidence intervals side by side, that's a way to do it. And then you can type collect style, put docx layout, auto fit contents, and that will it will keep the table from stretching across the width of the Word document. And then type collect export table 3, and that will create that table and export it into Word for you. So a couple extra steps there, and you can get your confidence intervals next to the odds ratios and then export them. Okay, so then how do we do this for multiple regression models? This is shockingly simple. What I'm going to do, this is the table that I'd like to see. I want to see a model for I want to see my hypertension model where I include only age in the model, only diabetes in the model, health status by itself in the model, and then I want to include all the covariates in the model together. And then I'd like to be able to compare those. So I've put things like the pseudo R squared and the AIC and the BIC at the bottom of the table so that I can compare these models and see them labeled clearly. See the output. I don't want to see the output. I just want to run the model. And after I run each model, I'm going to type estimate store and then give the estimates a name. In this case, I've named it age. And I've typed it with a capital A because I'm going to use these names in my table as the column headers. So I've given them a nice label like age with a capital A. Then I'm going to quietly run the logistic model, including only diabetes, and then type estimate store diabetes. And again, I used a capital D, so I can use this as my column header. So you get the idea. I run each of these models, type estimate store, give the model a name, and then in my etable command, it's exactly like it was before, exactly like the previous etable command. The only difference is I'm going to use this option that says estimates. So that's where it's going to pull the information from. It's going to pull from estimates. So I type in the names of those estimates that I store, where I typed estimate store age, estimate store diabetes. That's what goes here. So age, diabetes, health status full. And then I'm going to use the column option estimates to label the top of the columns with those estimate names. Everything else below here is exactly how I had it in the previous etable command for one variable. This is just our one model. So now I see age at the top of a column, diabetes at the top of a column, health status and full. And below that, I see the the odds ratios and the confidence intervals. Now, again, as it did before, it's put the odds ratio first with the confidence interval below it. So if I wanted to put the confidence interval next to the odds ratio, again, I can use that little collect composite define trick where I define ORCI as the combination of the odds ratio and the confidence interval. Run collect layout to see what the definition of the rows and columns, copy those into collect layout, and then when I run it, I get my columns here. I have an error, a syntax error that's not throwing an error, but I have an issue with why it's not putting those stars in there. Because see, it's showing the stars note at the bottom, but it's not putting the stars in here. I'm not sure if that's because I don't have space or what's going on there, but I will get that figured out before I put this up on the downloads. So we'll get that fixed. And so then I can type collect style put docx to squeeze the table or not make it stretch across the entire document, collect export table for, and that exports it to a Word document and it will look like that. Okay. So that's it. That's what I have for you today. There are actually two manuals. Table is in the reference manual. So that's where you would go. And I have a hot link here where you can just go grab the manual off the internet. And then the collect has its own manual. There's an entire manual devoted just to collect. These are incredibly powerful, flexible commands. So if you're going to do this, I strongly recommend looking at the manuals online. Michael Mitchell has written there in California. He's not far from you guys. Wrote a nice little book called "Create and Export Tables Using Stata," and it shows you how to do many of these things and tricks for customizing and things like that, how to use styles and so forth. I've written a news article on this. I think I wrote the news article, and I've written some Stata blog posts about this. So if you want to go look at the blog post, these are all hot links to them. I've also recorded some videos. I've recorded some other videos that just aren't up yet. They trickle these things out. These are back from Stata 17 when we first released it. And I don't think I have the D table and E table videos up on the YouTube channel yet, but they'll be coming shortly. So again, these are all hot links if you want to go see how to do this stuff. Again, the downloads, if you want to grab the slides, are here at tinyurl.com/statatables. And I will get these in there this afternoon, sometime this afternoon or this evening. So check back tomorrow morning and you'll have these slides that have been updated. Okay. So any questions? Oops. Did I stop sharing? I guess so.
You did, yeah. Oh, hey,
Okay.
Chuck, I just wanted to say thank you so much. I learned some new things that I'm excited to use. I appreciate
Oh,
that.
good. I'm glad. Thanks for being here.
Yeah, excellent as always.
Well, thanks. Okay. Any last questions?
I would like to remind everyone that there's a link to a survey, a very short survey in the chat. If you would take a few minutes to complete that for us, we would greatly appreciate it, as it really helps us offer new courses.
Thanks, Chuck. That was awesome.
Okay. Thank you very much. See you next time.
Thanks,
See you next
everyone.
time.
Okay. Bye.